Welcome to Leetcode JavaScript, a channel where we solve every single Leetcode question using JavaScript. Okay, right now we have question number 76, minimum window substring. This is a hard question, and it is hard, but it's sort of an archetypical question that once you know the answer to, you kind of unlock many similar problems. So it's a very important problem to practice if you want to get good at Leetcode. So it's relatively simple, and it goes like this. Given two strings s and t of lengths m and n respectively, return the minimum window substring of s such that every character in t, including duplicates, is included in the window, and if there's no such substring, you're gonna return the empty string. The test cases in this particular case are generated such that there's always an answer that's unique. And a substring, it's a very important concept to know, is any contiguous sequence of characters within the string. For example, A is a substring, AD is a substring, COD is a substring, and so forth. Let's look at a couple of examples because this might not be the clearest at the beginning. For example, here you have this S, which is a relatively long string, and T, which is shorter. We have A, B, C, and we want to know what's the smallest substring that contains these three characters and that appears first. And in this case, it's going to be this B, A, and C, which is all the way in the end. And essentially, it's the smallest substring that contains A, B, and C as shown here. But something you probably notice is the order doesn't matter. B is before A, even though here is A, B, C. Another example is when they're the same string, you just return the same string or the whole string of S. And in this case, we have double A and a single A. And since we have to have every single character including repeats, the output is going to be the answer string because we cannot form the string with the yes string, okay? So this question can be solved using either a hash map or an array. I much prefer using an array because dealing with numeric values that need to be constantly changed, as you're gonna see shortly, something that we do a lot with here. And you can probably also think there are many edge cases, which they are, and if you're using a hash map, you probably have to deal with them explicitly. But by using an array, we can not worry about those all that much, okay? So as I told you, we're gonna use an array here. And the way I'm building this array may not make a lot of sense to you, but I'm gonna explain it shortly. So we're gonna create an array of length 128, and we're gonna fill it with zeros. Why 128? Because we're gonna be using the ASCII codes of every single character. In JavaScript, you can just use the character, and that's something that is relatively straightforward. You wanna use a map instead. But we can take advantage of the fact that we can use the ASCII codes characters later on. It's also a good practice to just know them. So actually, I'm gonna store the result in an array initially, and I'm gonna have negative infinitive and positive infinitive as initial values, just because I wanna have some sort of bound of where my indexes are. Just for the example, let's say this is index 10 and this is index 14. I want to have from index 10 to 14 as the substring. And initially I don't really know where those values are. So I'm just going to use negative infinity and positive infinity just to make sure it much supersedes whatever the length of the string is. Additionally, we need to know what's missing. And initially, you're always going to be missing every single character of T. So you want to have every single character of T, and initially you're just going to be missing all of them. Fair enough, right? So we're gonna do a for loop through to a t, and this is a for each loop, a relative symbol, improved for loop. We said for let c of t, see it's every character of t, the array of, it's gonna be c that char code at 0. We're gonna increase that value with 1. And just so you can see how this looks initially, we're just gonna console log r, just to errors, and gonna return this. Okay, of course that's not gonna pass. Oh, and I make a little typo, good to know. Okay, of course this is not gonna pass, but I want you to take a look at how array looks. In this case, we're at t. T has a, v, and c, and here in this index, these indexes over here represent the value for a, v, and c, and we can access those relatively simply. Of course, you could subtract a from every single one of them to make the array shorter, but that's added complexity that I don't believe we need. But in any case, so once we populated this array, we're gonna start at 0 we're gonna be looking for the substring that we're looking for. So we're gonna start at 0. And we're actually gonna start by setting an end. We're gonna call this end is equal to 0. And end is less than s that length. We're gonna be iterating over the s string and plus plus. Great. So we start from 0 and then we span and try to find the substring. So if array as the char code at end is greater than 0, meaning if the element that we're currently looking at, if the character that we're currently looking at is present, we say missing minus minus, meaning we find it, right? Okay, so afterwards, we're gonna reduce the value that we just took a look at. And we're always gonna do it even if it isn't present, because we can find that if it's negative, it's just not present at all. Okay, now we need an inner while loop over here. So while missing is equal to 0, check that if result 1 minus result 0 result 0 is greater than n minus start. And this check is to assure whatever substring that we currently have is the smallest it can possibly be. And again, since the answer is guaranteed to be unique, we don't really have to worry about many having the same length or the same value. We just assume we're gonna find one that's definitely the smallest one. Then we're just gonna assign result 1 to end and result 0 to start. Okay. And an array that we have char called start, and we're gonna increment if we're using that. Okay. Now we're also gonna check after that if the char code at start is greater than 0, meaning if it's present, in t, we're actually gonna increment the missing, so we can count missing again for the next iteration, right? And finally, we're gonna do star plus plus. All right. Now, when we go after the loop, we can just return. We can return a value. And now, here's the thing. If result was never assigned, it could mean a whole lot of things, but generally it means that we cannot form the S. So we cannot form the T with characters from S, which can happen. So actually we want to check whether result 1 is equal to infinity. If that's the case, we return the empty string, as shown here. Otherwise, we're gonna return slice. You can also use Substring, but I'm more used to use slice. We're gonna send a slice that starts at result 0 and ends at result 1 plus 1, because slice is non-inclusive of the end. And let's try running this code now. And this is accepted. And we're gonna submit. And there you go. This is a quite optimal answer. As you can see, the runtime is only 86 milliseconds, faster than 99% of JavaScript online submissions.